Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the fascinating world of timing attacks. Specifically, a fun article on how to crack a secret using nothing but timing differences. Get ready, it's going to be a wild ride.
Timing attacks? Sounds thrilling. I'm all ears. What's the basic idea here?
Okay, so imagine a function that checks if a user's guess matches a secret password. Seems simple enough, right? But what if the time it takes to check the guess reveals information about the secret?
Like if it takes longer, the guess is closer?
Exactly. The article uses a starts with function as an example. If the guess starts with part of the secret, the function takes longer to return false because it has to compare more characters before finding a mismatch. This timing difference is the key.
So an attacker could repeatedly call the function with different guesses, measuring the time each time. The longer it takes, the closer the guess is to the secret. Clever.
Super clever. And surprisingly practical. The article even demonstrates a working demo, simulating a server using a web worker to avoid messing with the DOM. It's all done in the browser. It's amazing how much you can learn from carefully measuring execution times.
But wait, browsers have imprecise timers, right? Doesn't that make this attack harder?
You're right, that's a major hurdle. The article mentions that browser timers are often limited to 100 microseconds precision unless cross-origin isolation is enabled. That's why they need to run the check secret function many times to get statistically significant results.
I see. So more iterations to compensate for the noisy timers. But how do they actually guess the secret? Is it just brute force with timing?
Not quite brute force. They employ a smarter strategy called Thompson sampling, which is a technique from the multi-armed bandit problem. They treat each character as an arm, and they use the timing data to estimate the probability of each character being correct. It's like a sophisticated guess and check with statistical learning.
That's surprisingly sophisticated for a timing attack. So it's not just about measuring the time, but using that time data to guide the next guess. Interesting.
Precisely. They use a trie-data structure to efficiently store and update the probability distributions for different prefixes. It's a beautiful blend of algorithms and statistics. The article also discusses how to adapt this technique for network environments, where the noise is even higher.
Wow, this is way more complex than I initially thought. It's not just a simple, longer time means closer guess scenario. It's a full-blown statistical attack.
Exactly. The article concludes with some crucial advice. Avoid direct comparisons with secret values whenever possible. Use hashing or other cryptographic techniques instead. Even then, be mindful of potential timing vulnerabilities in those libraries. It's a great reminder to be cautious about how we handle sensitive data.
Definitely. This highlights the importance of constant time algorithms and secure coding practices. It's not enough to just make sure your secret is long enough. You need to make sure your comparison functions are secure as well.
Absolutely. This article is a fantastic illustration of how subtle timing differences can be exploited to reveal sensitive information. It's a must-read for anyone working with security-sensitive code. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the thrilling world of timing attacks. Have a great day.
Bye-bye.